Yes, sir. So the next question says, just a second. So it says, so humankind always finds a way to solve a problem. With time, new conventions and new rules are made, or old ones are bent. Before quantum, the classical would have been considered supreme, still we have drawbacks in it. So why is it that we look up to save time by using quantum computing? Because with new innovations comes new demerits and merits. It may be considered supreme till the time our problems lie in its ability to be able to solve and cope with our questions. This dependency of quantum computing will end once it collapses, probably due to our inability to control it. And then we will find another way and approach using another new computing manner. Is there any particular method that we may come up, or any other discrete ideas with some particle anomalies to develop our thinking around?
I think it's a very well thought question and comment. So first, let me tell them that quantum mechanics is not the final answer. There are so many things which quantum mechanics does not explain. And all of you know gravity. Gravity is still not well understood and is part of a quantum mechanical fabric. So quantum mechanics acknowledges it cannot explain dark energy, it cannot explain dark matter. So you must understand, science is not about the ultimate revelation. Science is progressively knowing more and more about things that you didn't know. So this is very important to understand, that while we are talking about quantum, we are not saying quantum is the answer. This is the best answer that we have to the challenges of what the world is about. But it is by no means, and everybody acknowledges that you can, and these are well-known problems which they can't. So this is how it happened. So we told you 100 years ago, we did not understand black body radiation. So this was created to explain black body radiation, photoelectric effect, this. The new phenomena will be found, and new ways will happen. So for example, one of the things I didn't say is that one of the things of quantum is teleportation. Many of you who would have seen the Star Trek, etc., beam me up, Scotty would be there. So we will have teleportation maybe to in some time. Instead of flying with aeroplanes or rockets, we will teleport ourselves from one place to another, and surely that would be there. So quantum mechanics is not the answer. It is the next step towards knowledge discovery. We don't know what to, and because people don't understand, sometimes people are relating quantum mechanics to consciousness, quantum mechanics to life, and all kinds of things. Quantum healing is a word which is very popular, which is very related to. So first thing is, I think this person is very well understood that the frontiers of knowledge will always be growing and expanding. And when we are finding new phenomena which cannot be explained on the basis of what we already have, then we start talking about this thing. So by no means is quantum the thing, and that's why I'm saying quantum is the immediately useful thing. Okay? Yeah.
So the next question says, where do positrons exist? And if they do, which electron reacts with it?
No, positrons can exist in a number of materials. Just like, see, the point is, with what ease can you get a positron out of the material? They are together. So just like when you apply a field, you can pull an electron out, and those of you who have some more idea, there is a certain thing called the work function, which is required to pull the electron out. So in the positron case, it's a negative work function, and you create that, and that's how we said all these devices like PET devices, etc., are available. So there are certain things where the positrons are easier, just like for electrons, we use a tungsten filament or something where the work function is low and the electron can come out. Similarly, there are special materials which will be used for where positron density is high, the potential barrier is low, and they are brought out.
So the next question says, so are designing a pathogen for biological warfare and quantum mechanics related to each other?
See, at some level, you can have a lot of biological weaponry without quantum mechanics. So, simple nerve gas, this, that were there. It is only when you come to the operational level, you might find that quantum has an advantage somewhere. So, for example, I read somewhere that they were doing experiments with mice and psychologists, and they found that the one which had lithium-5 had a certain behavior, somebody who had lithium-6 had a different behavior. So it could be there. And in fact, quantum can give rise to the most important part of quantum is that it can do a lot of very interesting remote action. So much more than the traditional things, but they will all be, sometimes they will be just used to trigger something remotely, like, remote control bomb. So the thing may be there, and yeah.
So the next question says, so isn't it possible that quantum supremacy can make countries compete with each other? Isn't that kind of technology dangerous in that regard?
You see, this is a very interesting point, that science got pursued out of curiosity by the scientists. But then the power that could unleash was enormous. And I'm very happy you raised this question, because the first time we saw the destructive power of science was in the nuclear bombs explosion over Hiroshima and Nagasaki. Till then, science was in the labs or a little bit, etc., etc. But as a weapon, it was used for the first time in this massive destructive way. It also gave a lot of respect to science, because then they realized that the scientists can really do a lot of damage. So this is a very important issue of all things. So that's why, in fact, that is why the countries are racing. So the next was the space race. And you know that between 1945, say around 1945, US assumed the most powerful country in the world because they have the technological power. And Russia was following, but the Americans believed that Russians are copying us, stealing our secrets, etc., etc. It was only in 1957, when the Russians launched the Sputnik, that the US realized they are left behind. And when John Kennedy took oath, he took oath in 1960, his first address to the nation was, within the lapse of 10 years, we will take an American to the moon and bring him back. And on 22nd July 1969, Neil Armstrong actually set foot on the moon. The famous phrase, one step for man, giant step for mankind. So since then AI is the thing. So today the battleground was AI. That who will have an AI which will give them greater power. And there's a whole thing about automatic weapons, automatic robots which will go and kill, automatic bomb dropping, automatic weapons, and so on. And this is one of the big issues upon AI and ethics and so on and so forth. There is a very nice book which I read. It's called Army of None. So we used to talk of one-man army. This is an army of none, because it's just robots which are going to go and do this. And drones and robots in formation can do huge amount of destruction. So the point is that this is the big issue, that how will humans respond and react to all these technologies. But the problem is that human science is driven by curiosity. We all like to do things which are considered impossible. I mean, you are a school teacher, if you tell children not to do something, that is exactly what they will want to do. so this is the point. And it's a very large question, but important thing and a fact of life.
So the next question says, is camouflaging, can camouflaging be related to quantum mechanics?
Yes, see, the point is very simple, because again, when we talk of quantum mechanics, we have to look at two kinds of things. Something where we are looking at things at the quantum level, where the other is where quantum mechanics is happening, but we don't care. So like I said, photosynthesis is happening in the plant. So all plants around you are quantum mechanical devices which are doing photosynthesis, but we are not, in a sense, interfering with them. So whenever you're looking at camouflaging, and we are looking at camouflaging in I don't know, he's talking of aircraft carriers and aircrafts being camouflaged, or he's talking of some light being camouflaged. But basically what you're saying, you see anything because of the light that has been reflected from them. If you put a sufficient absorber there, then the light will not be reflected. That is how you would do it. That's how you protect yourself against the radar and so on. And to know what vibrations or what are the frequencies of that light, that material from first principles, you will use quantum mechanics to calculate them.
Right, sir. So the next question says, so can quantum computing also be applied to the field of aerospace and outer space engineering?
Yes, they are already at it. So it is, very often we tend to think of some very complex thing as well. So I just saw an interview dialogue between Accenture senior person and an Airbus senior person. So forget anything else. If you have you look at things like Boeing or Airbus, etc., the number of sensors that they have in their aircraft is in thousands. The amount of data they're collecting is in petabytes. So therefore, for them to process that amount of data, they need a faster thing, and which is where the quantum computer comes. So let me also explain for everybody that we will not always see two kinds of things, that this is done by a classical computer, this is done by a quantum computer. One of the very first usages of quantum computer is in extending the power of a traditional problem. So artificial intelligence today is a well-defined field. Deep learning is a well-defined field. Machine learning is a well-defined field. But when, as we said, the number of calculations required for the machine learning model may become very large, you take it to a quantum computer. So the new buzzword, which will be immediate, is called quantum machine learning. So you talk of machine learning, but being implemented with a quantum computer. And many of you have some idea of this, is that when you do things on a computer, the processors that you use for a particular problem can change. So you use a CPU, or you use a GPU when you're doing games and graphic work, or you use a TPU, which is a tensor processing unit when you do some AI with Google TensorFlow, etc. And now you will have a QPU, quantum processing unit. So you will do that problem, and when that comes that this problem will now take thousands of years to do on this computer, it will be pushed to a quantum computer, solve that, come back, and integrate it with the rest of the thing.